to ask you.
Are you a Mac guy or a Windows guy?
Well, I guess if I had to pick one of the two, I'd probably say I'm a Mac guy, but I run both. I mean, I have a 5K iMac at home that's running Windows 10 right now. I play World of Warcraft a lot, so yeah.
Dota?
Huh?
Dota?
I don't play Dota. No. Yeah, I play World of Warcraft. More into MMOs than I am into.
MMO? You can try Dota.
Well, Dota's not an MMO. Dota's a. No. No. It's not. It's. I know the kind of game it is.
But as far as I know, it's one of the biggest MMORPGs out there.
No, Dota. The type. I'm trying to think of the name of the kind of game that Dota is. Dota is the competitor with League of Legends.
Yes.
It's a MOBA.
No, League of Legends is a competitor to Dota.
Fine, whatever. But they're the same genre of game. Those aren't MMOs.
Same genre.
Yeah, those are called MOBAs. MOBA. Massively online battle. Something like that.
I know what I heard and what I read about it. It's MMORPG.
I'm pretty familiar with the differences. It's not. I mean, it's one of the most popular games out there, but it's the type of genre is a MOBA. It's.
So you told you like golf, right?
Yeah.
So you can try Dota.
Oh, I have played Dota and I've played League of Legends. I don't like the those games where you play like a single game and it lasts 20 minutes or something and then you start all over. That's not interesting to me.
It's you played Dota or Dota 2?
Just the original one, I think.
Original is kind of sucked, but you got Dota 2 right now, and there's also this year the prize money was 20.
Well, yeah. That's for the competition. But what I'm saying is that when you play the game from a fun perspective, every 20 minutes you're starting from scratch because it's a new battle.
No, the game goes on for like 40 minutes.
Oh, whatever. 20 minutes, 40 minutes. It's a period of time, and at the end of it, then you start over.
Like to continue your
Yeah. So like World of Warcraft, I have a character that I've worked on for a decade. When I started the game, and so I have a bunch of gear, and I keep upgrading my gear, and so it's.
a lot of money right there.
Yeah, I mean it's true. It is true. So.
So these games are better than those Battlefields or the other game.
Well, they're not better. We can connect this right back to the thing we were talking about, the programming languages. You have games like League of Legends and Dota. That's one genre of games. You have real-time strategy games like StarCraft. Okay, that's another version. That's another kind of game. You have games like Battlefield and stuff like that, which are first-person shooters, FPSs.
Yeah.
That's another kind of game, huh?
What kind of games are you in?
What kind of games do I like? I like MMOs. I like games that are like long-term character development. You make your guy better playing in an online world. So I like games like World of Warcraft, EverQuest, EVE Online, those types of things.
Console or PC?
PC. Yeah, I mean, but when I was younger, I liked console-type games. Now I like less twitchy stuff and more storyline, I guess, stuff like that. So, like, I don't like the first-person shooter games or anything like that, but they're really popular, right? So, Battlefield, Counter-Strike.
Battlefield, Call of Duty.
Call of Duty, yeah.
And it's like 130 GB installation size.
Yeah.
It's pretty big. I mean, that is the largest installation file size up until now.
Oh, what's the installation file size?
130 GB.
130 gigabytes? Okay.
That's pretty big.
Yeah, that is big. Like World of Warcraft is, I think, 28 gigabytes.
Yeah, then you add on DLCs and all that stuff.
Yeah. Well, and that's with everything. That's and that's a pretty big install for normal games.
So that's with everything?
Yeah, that's with everything.
That's just a game. That's just the story.
Yeah.
And you can add on zombies and all that.
I see. Oh, I gotcha. Yeah, so just different games appeal to a different audience. Just like programming languages, I don't get anything out of sitting there shooting zombies. I don't get anything out of doing a 4 versus 4 or a 5v5 thing, and somebody wins running the map or something like that. It doesn't do anything for me. But I have several students and friends who just love those games. They're like big into them. You know, they follow all the world championship stuffs for Dota and all that stuff, and so I mean, I get it's just not it's not for me.
They're like my emotions, you know?
Yeah, no, I get it.
So not liking Dota is like hurting my emotions.
Well, but understand, I don't dislike Dota. I dislike that genre of game. It's not fun for me, huh?
You don't like the whole thing?
Yeah, the whole genre isn't fun for me. You know, I can sit there and play it for a half hour or 45 minutes, but doesn't have staying power for me. It's just my own personal taste.
Because I don't like that thing you're playing.
Well, and that's pretty common. Actually, in fact, you know, so you reference like esports. So if we're going to keep this connected to you know, computer science at some level, you know, the idea is that so games like Dota, League of Legends, these have like competitions associated with it. They're effectively esports, right? In World of Warcraft, the esport aspect of it is in PvP, the player versus player, the battle, you know, human versus human, which is then moving it similar into, you know, a Dota type thing, where I don't play PvP in World of Warcraft. I play PvE, where it's more raids and killing giant bosses and that kind of stuff. I find that entertaining, and there really isn't an esport version of that because that's much more about learning game mechanics against the AI rather than competing against a human.
Oh, so you're interested in knowing how
The mechanics and the fight and the contact, you know, rather than trying to predict what a human being is going to do next.
That's
So,
perception.
like, I would say I'm pretty good at PvE in WoW, but I suck at PvP. It's too fast paced for me. I can't keep
That's
up.
why you hate Dota.
Yeah, I think so. Yeah, I'm not good at it. The same thing's true with like the first person shooters. I mean, you know, it's too fast paced. I can't keep up. So before I know it, I'm dead. So, you know, and then, you know, if I play with some students or something, they'll just shoot me. So I get, you know, when I run out of ammo, then they shoot me, I die, I get a gun back. Because when you come back, you get a new gun with new ammo. That's the best way to get new ammo, is to die and come back. Yeah. So, I mean, it's
What
just...
was the reason that Destiny became so famous? Destiny, that's
Okay, well, so Destiny is effectively a first-person shooter with a MMO-style storyline to it. So there's like raids and bosses and stuff like that. But I mean, I played it. It's more first-person shooter than it is MMO, at least for me.
Yeah, it is kind of.
And really, what it comes down to, what it really I think comes down to, is skill. I think it takes a lot more skill to play games like Dota and first-person shooters and stuff like that than it does to play World of Warcraft. Unless you play PvP in World of Warcraft, then it's more of a skill thing. But so I guess I like games that require maybe less twitchy skill because I'm older and I can't keep up. Maybe that's it. I mean, that might be it.
You're busy with a lot more stuff.
Well, no, it's just as you get older, I mean, you know, things slow down.
So you can say that I'm a genius in these things.
Oh, I wouldn't bet you money in Dota. You'd kill me.
So I'm a genius.
I guess so. Yeah. I mean, I've never seen you play, but I'm very confident you would beat me. But that's not saying anything.
See, I got you.
Yeah, but you being able to beat me in Dota literally says nothing.
But still, I got you somewhere.
That's a start.
I bet you could probably also beat me in a foot race. Foot running?
Yeah, I can.
Oh, I'm confident.
Yeah.
Yeah. So I mean, there's two things.
He's thinking in that good way. Good start.
I have incredible burst speed from like here to the fridge. Very quick from here to the fridge.
Oh.
And I got to rest and cook my bacon.
Yeah. I've
Alright.
seen a lot more food on that. Yeah, it is really makes my mouth water and say, oh, I missed this one.
All right, so let's jump over to the native side here and kind of get through this quickly so we can start talking about some data structure stuff. So all of these languages, again, also come from C, okay? And just like these all came from C, so this is language from 1968. pretty old language relative to us today, I guess. Now, these languages, we want to talk about the pros and cons of these as well. So what I'm going to do is I'm going to come up top here, and I'm going to write procedural next to this guy. And then we're going to come down here. I'm going to say there are two kinds. Actually, I'm going to say three kinds, but I'm only going to explain two of them. We have procedural, we have object-oriented, and then we have functional. Okay, functional. I'll just give you like a quick glance over description. So if you've ever had like a Texas Instruments graphing calculator or something like that, where you solve problems by passing functions into functions into functions, like the sine of the cosine of the tangent of x, that would be a functional language where everything is kind of self-contained inside of individual functions. That's a really bad description. You really need to see a language, a functional language. So functional languages would be languages like Lisp, Scheme, Pascal. Those are some functional languages. They're used mostly in like an artificial intelligence and some things like that. I teach in the undergrad curriculum. I teach a programming language theory class where we write our own programming language, and in there we actually use Scheme to implement a programming language. Functional languages tend to be pretty small, so it's a really short learning curve to learn the language. So you're mostly, but it's also because it's so simple, you have to use it to build larger constructs, right? So think of it like Legos. So you're given a relatively small number of Legos. So what you have to do is you have to use those small Legos to build more powerful Legos to be able to solve problems with that. Something like that. All right, but the two we really care about for a modern programmer, we're going to say, is procedural versus object-oriented. All right, so procedural languages. So I usually send these guys tend to be monolithic in nature. Everything is linear, one instruction after another. And if you just to kind of connect this back, I want you to think of a procedural language as kind of like the problem that we talked about earlier with PHP. It's not that it's broken. It's not that there's anything wrong with it. But as you start solving more and more complex problems, things just get really like embedded. You have all this code, just a mind, a mindstorm of code. It's a wall of code in front of you, and it's not modular. You don't have some of your code here and some of your code here and some of your code here. It's just boom, okay, like that. Now, the example I usually give is, let's say you walk into the room and over here I had a big pile of wires, okay, and I tell you that's a telephone. And you look at me, you're like, oh, okay, whatever. You come up, you inspect it a little bit, you find the handset, you find the buttons, and you lift it up, you hear a little dial tone as if that exists anymore. But ultimately you're convinced that, oh yeah, it didn't look like a telephone. Sure enough, that was a telephone. A pile of wires was a telephone. That's the procedural version of a telephone. Make sense? Now, object-oriented version of a telephone. So let me just give you the example first, and we can try to put some words to it. But that guy will look like a telephone. All right. Now, if you walk in, you see a telephone sitting there, you can identify it. If you walk into Target or Meijer and you go to the section in electronics where the telephones are, there's going to be 5 or 10 different kinds of telephones there. But you would be able to identify all of those as telephones because you know generalistically what a telephone looks like, right? Okay, even though each of the phones might look a little bit different. You can identify all of them as telephones. And you know that they're a plastic box, and inside of it, all those wires are stuffed in there, right? All the wires are still there, just like the procedural telephone. The difference is that you took all those details, you shoved them inside the box, and you only poked out the parts of it, the public interfaces that you actually had to deal with. right? When you actually use a telephone, all you're using is the handset and the buttons. You know, you don't need a majority of those wires in there. They're important. They need to be there to work, but you don't interact with them after it's built. So you hide them inside of the object. Make sense? So usually I'll say something like, all of the details are present. Say this again.
Abstraction?
Abstraction would be a good thing. So so we could say that an object-oriented telephone is an abstraction of the procedural telephone. It's a simplified version from the outside, even though all the details still exist on the inside. So all the details are present, but the let's just see, but only the public interfaces are exposed. Make sense? So the object-oriented telephone looks like a telephone, and all the parts of it that we actually need to use are available to us. The buttons, the handset, the important parts, okay, from a usability perspective. Even though all those details, some smart person somewhere working on an assembly line or something like that put together this telephone, and in order for it to work, all that details inside the box had to be there. But once it's there, we don't have to worry about it. Okay, same thing back at our house, right? We know we have electrical wires and stuff inside the walls, but we cover it up with drywall, and we don't worry about it. Okay, only the public interface, the plugs, the switches, only those things are exposed to us. That's object-oriented programming. Make sense? Okay. So what's kind of interesting about this is, and this goes back to what I said earlier about this idea that we have all these buzzwords and they usually mean easy things. It's very easy if somebody asks you what's the difference between a procedural language and an object-oriented language to get caught up and try to give this really technical description difference. At the end of the day, it's Tupperware. It's organization. What's the difference? I took a procedural language, I took all those wires, I threw it into a box. I poked a couple of holes in the box and squeezed out the parts of it that I needed to work with. Boom, object-oriented programming. It's organization.
Same thing is organized.
Yeah, all it is. So, I mean, it's so easy in your mind to say, oh, it's something so much bigger. Why does it exist? So if we go back here, we had a procedural language here, which then we evolved into an object-oriented language. Object-oriented programming. So C++ is object-oriented programming. Why do you think we needed that jump?
To let other people who are unaware of programming interact with it.
So reducing the complexity, as we discussed.
Okay. I want to go down that line a little bit. So you said reducing the complexity, right?
Yeah.
Why did we need to reduce the complexity?
Like we took an example of a telephone system, right?
Mm-hmm.
Instead of giving all the bunch of wires to the user, which are useless, right? Make it easy to use,
Okay.
right? So that number one, it is easy to use.
Mhm.
Number two, it will be safe. Then the users will not pull out the unnecessary, wires
Okay.
and stuff that working off the telephone.
Why didn't we do it to begin with? Why did we make a procedural language instead of object-oriented to begin with? I mean, as human beings, we've been organizing crap for a while, right?
Yeah.
We didn't just start putting stuff in drawers. Right? We've been using drawers. So in 1968, did people use drawers? Did we put our socks in drawers in 1968? Yeah, we organized stuff. We put dishes up in cabinets in 1968. We put our socks in drawers, our underwear in drawers. We organize stuff. That's what people do, right? Even us guys, we're slobs, but we organize a little, right?
What I have learned it last time is that if we do some kind of programming and we do it procedural, if next time we have to update something or improve something within the same thing, it would be really hard for us to go through everything rather than going through the main points where we have to make a change. So what object-oriented made it made like everything is in separate like drawers. So we know this, if we have to upgrade or do something, change, in particular drawer, I would go to that drawer, pull it up, and do something rather than going through all of them and wasting our time and wasting
Okay.
resources.
Everything you just said is true. But I'm still looking for the reason of why. Why did we come up with procedural first? We knew about drawers. This was 1968. We're not talking about cavemen. 1968. This isn't that long ago, right? We had cars. Cars existed. Okay, they had glove compartments. So we had drawers. Okay, so why would we waste our time with a procedural language when clearly the object-oriented language is better? Clearly, you're saying the object-oriented language is better. Why? Are we just stupid? What's the why? The why is the important part here.
Maybe the necessity, the applications which existed during that period was not very vast and complex. Simple.
That's exactly it. That's exactly it. We got to consider, we think of computers today as these powerful tools. 1968, people didn't have computers sitting on their desk. We hadn't completely imagined everything we could do with these things. You know, a computer in the early days was basically the evolution of a typewriter, right? You see what I'm saying? We weren't solving humongously complex problems. A procedural language was fine. We weren't building telephones. Okay? We were building straws, right? You know, we weren't doing anything that complicated. So as our computers got more and more powerful, and as human beings' imagination and our, got the best of us, let's say, and we started thinking, hey, could I do this with a computer? Could I do this with a computer? Could I do this with a computer? We started solving more and more complex problems. And all of a sudden, we start finding ourselves with problems that are becoming more unwieldy. All right? If you have a project you're working on that only has 3 wires, not a big deal, right? You know, when you're organizing your home entertainment system, if you only have like 2 HDMI cables or something like that you need to hide, you just kind of stuff them back behind there. Right? But if you've got like 30 wires, you got to start zip tying them and getting everything organized. Otherwise, it's just a mess, right?
Color coding.
Yeah, whatever, right? So as the problem, you're exactly right. As the problems became more complex, we started seeing the issue with our current tool. It's like, this guy's not really keeping up anymore, right? Make some sense? All right. That's where we came up with a object-oriented language. So what's C++? C++ is the C programming language with object-oriented extensions. Okay? Comes with Tupperware. Comes with drawers. Allows you to build that telephone object. Shove all the stuff inside of it and only poke out the details that are important to you. That's it. That's it. They look identical. The Hello World program in C++ is identical to the Hello World program in C. They just provide you with a new I/O library if you would like to use it. So in C, you would use the standard library, which is standard I/O. So you would do printf Hello World. In C++, you can still do printf Hello World, so you can make it identical, or you can use IO stream and do cout Hello World. It's the same. It's the same.
Just a different way to say
All right.
it.
So now, Java. So now we got to figure out what's wrong with C++.
More complex.
Yeah, see, we can't just keep falling back on that, right? It's like, well, it's more complex, more. Okay, because we kind of saw the evolution happen over here, didn't we? All right, so now the storyline related to Java comes down to this idea of programmers making bad decisions. Okay, so what I like to say is, let's just do a slide here for C++. Empowered bad decisions. All right, so as a programmer in C++, as well as C, so this problem existed all the way back to C, but it wasn't the main problem in the C days because complexity caught up with us. So that's why we needed C++. We needed the object-oriented extensions to C. Well, now, as C++ programmers, a programmer, especially beginning programmers, are empowered to make poor decisions. Poor choices. All right. And here's an example. So let's say, which of you are, you got to be the party animal out of this group. You throw parties and stuff, right? Oh, come on. All right, so he's inviting me over for a pizza party. Okay, Little Caesars, old Little Caesars. I'm low carb. It's cool. All right, so he's going to invite me over for a party. Now, how does this conversation go? Does he say, "Hey, come over to my, I have a party at my house tonight at 8." Does he hand me the house and tell me to open the door at 8 p.m.? Or does he give me the address where his house is and tell me to come to his house at 8? Yeah, the address. Would it ever make sense for you to actually hand me a house? They're heavy. Houses are heavy, right? We can all agree. Even small houses, they're heavy. We don't just carry those things around. In C++, a programmer could choose to hand somebody the house. Now, you got to go back to the days when C++ was still the most popular language. It's still popular today. So let's go to the early days of Java, probably 1994 or so, something like that, when Java first started coming out. So prior to that, so we go back to 1994. So let's kind of think about system resources a little bit then. So you guys all have computers in here? Okay. How much memory is in your computer? System memory?
4 GB.
4 gigabytes. Okay. What about yours? 8 gigabytes.
No, new one 16.
16 gigabytes. Okay. So 16 gig. Okay. Now, okay. So you have 8 gigabytes. Now, if you wanted to double the RAM in your laptop, or is it a desktop, laptop, whatever, if you wanted to double that to 16, how much would it cost you?
Around $150.
Probably less than that, because 8 gigabytes is only about $40 or so.
Yeah.
But you're saying you might have to replace all your RAM.
No, it's soldered to it. So
It's who?
it's soldered to it.
Oh, okay. So you got a specialized type situation. But generally speaking, 8 gigs of RAM is about 40 or $50. It's cheap, right? RAM's cheap. So now in 1995, 94 or 95, I had a computer. And how much RAM do you think I had in my computer in 1995?
65 and
256 megabytes?
something.
I'll tell you what, if I had 256 megabytes in 1995, okay, I would have been the talk of the town.
It was
Way less than that.
64.
Well,
I had 8 megabytes of RAM in that computer. And that was bleeding edge. Computers did not come with 8 megabytes of RAM back then. They came with 4. 4 was considered a good computer. 8 was ridiculous. 8 megabytes back then was kind of like the computers that come with 32 today. Get where I'm coming from here? So I decided I wanted to double my RAM about a year later. So I wanted to add an additional 8 megabytes, making my megabytes, not gigabytes, megabytes. I wanted to add an additional 8 megabytes to bump my RAM to a total of 16 megabytes. How much did 8 megabytes of memory cost me in 1995? We just said that 8 gigabytes today costs about $40. How much do you think 8 megabytes?
I think $1,000, maybe plus more.
$1,000. $1,000 for an 8 megabyte chip. Now you weren't ready for the punchline? This was after memory had already started dropping in price. It used to be more expensive. Famous guy once said, "You'll never need more than 32K of memory." You know who that guy was?
Me?
Nah, not you. This was probably said before you were. Well, yeah, he was definitely said before you were born. Bill Gates. You know Bill Gates, Microsoft dude. Yeah, he once said, "You'll never need more than 32 kilobytes of memory." Kilobytes. KB, not MB, not GB. KB.
Yeah. Oh, why he said it?
You got to go back. We're sitting here in 1968, 1975, 1982. It's so hard for us to see. I mean, we sit here today. What's computing going to look like in a decade? In 15 years? In 20 years?
It will be something
Completely
automation.
virtual reality, holograms.
We're using our imagination, right? We're trying. We would just be guessing where it's going to go. Even internet speeds today. I mean, what's your internet speed at your place? How fast? You have 80 megabits per second, right? Not bytes, megabits.
Small bits.
Yep, small b. Okay. So what do we got? Huh? You have 80? Okay.
Yeah, I think I have more than that.
Who's your provider?
It is this Time Warner, and we pay $80 per month.
Okay.
And
And who's your provider?
Comcast.
Okay, so you're Chicago area?
Yeah.
Okay. You're same thing?
Time Warner.
You're Time Warner.
Yeah.
Okay, so you are probably actually getting 60 is my guess. You're in Milwaukee area?
Yeah.
the download
Yeah.
speed and up
The
speed
download's faster, but whatever. So
Yeah.
60 megabits, right? Now, you've heard of a T1 connection, right? T1 network connection. You hear about it in movies. People get a dedicated T1 to their house.
Or like
Yeah.
static something.
Yeah, static IP address, a dedicated T1. So you get your data is piped directly in from the phone company rather than working through like a vendor like Time Warner or something like that. So would you trade your 80 megabit per second Comcast cable modem for a dedicated T1?
It will be better.
You think yes?
It's gonna cost me a lot.
Oh, it'll cost you an arm and a leg. It absolutely would.
I think we-
But I'll tell you what, I'll pay for it. I'll give it to you for free. You get to choose one. Okay? You want the T1. So T1's probably going to be, today's prices for a T1 is probably, it's a lot less today than it used to be. It's probably about $500 a month would be my guess for a dedicated T1. But I'll buy it. I'll buy it for you. So you'd rather have the T1? I mean, we're going to trade. So you want the T1, I'll get your 80 megabits? Okay. What do you think your internet speed is now with that T1?
A lot, because I'm not sharing it with anyone.
It's true, you're not sharing it. It's dedicated.
Maybe the maximum speed, maybe 800 megabytes or 1 Gbps.
200 megabits per second?
Maybe 1 Gbps.
Oh, 1 gigabit per second.
Maybe.
Yeah, it's a 1.44 megabits.
What?
Yep.
I thought they were developed now.
So is it the concept of that like net neutrality? You get the dedicated or something?
Don't overthink this. That concept of, T1s are really fast. Well, if you're back there with a 14.4 dial-up modem, a T1 is ridiculous. Okay, back then people would pay hundreds of dollars for fractional T1s. But a T1 today is almost unusable.
So you got higher ping latency and all that over there? Or
Won't make a
same
difference.
thing?
No.
Doesn't make a difference?
Because we're separated by 20 years. Okay, we're separated by 20 years. 20 years ago, T1s were awesome. Today, T1s belong in a museum for internet connectivity. T1s are mostly used for like security systems and things like that today, when you need a dedicated on-call system that isn't dependent on lots of data. Okay? So the idea is that as time moves forward, our perception of what is fast, what is big, all that stuff changes, right? Today you go out and you get a, if you go to Best Buy today and you buy a big hard drive, what is it? We're probably talking a 3 terabyte hard drive, something like that is one of the bigger ones. I think they make a bigger one than that, but that's kind of on their larger size of hard drives today, about 3 terabytes TB.
Yeah.
4, whatever. Yeah, fine. Well, 3, 4, big hard drives, right? How big of the hard drive? How big was the hard drive in my my PC in 1995? 10 gigabytes?
Yeah.
Okay, no, less.
Because I had
How much?
64 KB.
Oh, 64 kilobytes.
Yeah,
Oh, see, he overcorrected. Yeah, he overcorrected.
Because it didn't have RAM.
Because remember, I have 8 megabytes of RAM back then. So I had 8 megabytes of RAM. How much hard drive space did I have?
Maybe 256 or 5.
Yeah, you're in the ball. So I had a 420 megabyte hard drive. Yeah. Okay, and I wanted to upgrade that to a gigabyte. So I basically bought a
Yeah,
600
maybe.
megabyte hard drive. I think it was a 580 megabyte hard drive.
I,
How much do you think a 580 megabyte hard drive cost me in 1995?
crazy. Maybe around $600-700 for that.
$1,000. Where a
It was
3
impossible.
terabyte drive today, retail is
150.
yeah, $120, $130.
Terabyte.
If you order off Newegg, you can get it
Even
for
the
one
SSD,
110. Huh?
Even the static drives now are.
Oh yeah, serial ATA drives, yep. Or not serial, the solid state. Solid state is what you're
Yes.
talking about. Yeah, so
They are not much.
as time moves, our perception of what's fast, what's big, all that stuff changes, right? Now, so getting back to what we were talking about here, where a programmer was empowered to make bad decisions with a language like C++. Back then, if you chose to hand somebody the house versus hand them the address of the house. So if we're putting this in real life terms, a house is really, really, really heavy. An address is really, really, really light, right? So you're saving a lot of memory
Oh yeah.
by handing them the address rather than the house. Back then, we cared a lot because memory was expensive. It was really expensive. Okay, how many of you have heard of the Y2K bug?
Y2K.
Y2K bug.
Yeah, 2000 problem.
Okay, what was it? What was the Y2K bug?
I guess it was related to year 2000.
Yeah, it was.
Yeah,
So far, so good.
the date format we were using was 2 digits for year. Like
Why?
98, 92, something.
Okay.
But when it goes to 2000, it starts again from the beginning, 00.
No, when you get to 2000, you can't differentiate between 1900 and 2000. They're the same year if you only are storing 2 digits. Why were we only storing 2 digits?
To save memory.
Memory,
Yeah.
right?
Same memory.
And we could replace memory with money to save money. And before we were trying to save money, it was because you couldn't physically put more memory into the machine. Okay? So memory used to be a bottleneck. In early computing, well, we say early computing, not relatively recent computing, memory was the bottleneck. Today it's throwaway, right?
Everyone have tons of.
I mean, you could put 32 gigs of RAM in your machine without breaking the bank. I mean, he just skips pizza for a month and he's got more RAM, right?
Yeah.
I mean, the point is that we're not talking about thousands of dollars. We're talking about $100 for to max your RAM. It's not expensive anymore, right? So today, it's less of a big deal if we hand somebody the house. Yeah, it doesn't make any sense in real life, but he can lift it.
Yeah. Have memory.
So how big's your house? 600 megabytes? I got room in the back. Right? Because he's hauling 16 gigs.
Yeah.
Doesn't even feel it. Who cares?
Yeah.
All right? But back then, it was a big deal. Now, having said that, even if you could lift a house, wouldn't it still make more sense to give them the address? At some point, logic has to intercede, right? Has to intervene and say, look, fine, you could lift a house. Nobody's impressed. I'm a little impressed, okay? But, here's the address. Just meet me there. It'll be easier on all of us. Okay, so this kind of comes down to good programming, and this really is a kind of almost a lost art, and it's really a reason why I focus so much on some of these older technologies. And trust me, your homework assignment for next week is to do an Android tutorial. You'll be dealing with new technology. But I really like to focus on the old stuff because it tells us where we came from. And it gives us an appreciation for how we got to where we are today.
Why
And
we
it's
are doing
so
it.
important. It's so important for understanding the complexity of technology. And it's really important, I think, for IT professionals because you can translate this directly across the board and say, well, why does this hardware work this way? Why does this work this way? Data speeds are a big deal. Okay, so I mean, you're trying to get a master's in IT. You didn't know what a T1 connection is. I mean, Pepperoni or Italian sausage?
Pepperoni or
Tomato sauce.
Oh, you don't do the meats.
pepperoni pizza.
Pizza. What kind of pizza?
Pepperoni pizza.
Cheese pizza.
Just cheese pizza?
That's the cheapest.
Oh, that's it. That's the cheapest. Is it really?
Cheese
Little Caesar is cheese any cheaper than pepperoni? I thought they're both $5.
No, they were same.
Oh.
Pepperoni and the
I
other
didn't
ones are
know
same. But we are we don't eat pepperoni.
Huh? Yeah. That's what I was asking. If he doesn't do the meats, right? So it's no beef, no pork.
No pork.
You do chicken, right?
We
No,
do
we
beef
eat
too.
it, but in kind of a different way.
Actually, only the Hindu religion cannot eat beef.
The beef, okay.
Because they consider one of the gods.
Yeah, I understand.
They have
Yeah.
300-400
But so pork's out. But chicken, you're okay with chicken, right?
we are okay with everything except pork.
But then-
It's like a general rule that if an animal is a vegetarian, doesn't feed on another animal. You can eat it.
Okay, that makes it clean or whatever. Okay, got it. Yep. See, I'd have a real problem with no bacon.
Yep.
I mean, that would just be a deal breaker for me. I go to my cardiologist, and every single time I go in, he's like, you gotta lose some weight. I said, oh, so we can talk,
Okay,
but here's our starting point.
Not this.
I'm not giving up bacon. At any point in time, I have a 5-pound bag of bacon in my fridge. I keep them in a bag. I buy it in bulk from the butcher.
That is too.
I just love
Yeah, I have seen on your breakfast. And
I
everything,
love bacon. It's so
and
good.
Steak, steak, yeah. You can get it confused.
All right, so our punchline here is that we lived in a different world, right?
Yeah.
But even today, good programmers would remember this stuff. Now, having said that, sometimes we can make strategic decisions today which allow us to make a less than a memory efficient choice, maybe to make up for it in speed because we can lift it, right? Today we have the space. We can choose to do that if we want and have a good reason for it. Back then, you as a beginning programmer, you didn't know what you were doing. You accidentally passed the house instead of the address to where the house was. Okay? So this was the problem with C++. So this is where Java comes in. So what does Java do? So if we're going to give kind of the highlights of Java here. So Java took memory away from the programmer. Okay, we're no longer in charge. We don't get to choose whether we're passing the house or passing the address of the house. If we're going to hand an object to somebody, it's by address. Done. Java made the call. Right? Not our problem. Off the reservation. Okay? So this took memory away from the programmer. It also moved performance into a virtual machine, to a VM. What does that mean? When I say virtual machine, what are we talking about?
Virtual machine is which is not like physically, but it does everything.
So it's like a computer,
Yeah, it is.
but it's written in
Like
software.
so many,
It's a computer made of software.
It is a small software.
So we have the CPU, but the CPU is a program, right? A piece of software that mimics a CPU. So a virtual machine is a computer written in software. Okay? Why? Why do we have virtual machines? What's the benefit of them?
We can, if we have to do testing or things like with the different computers you can have a virtual computer on your system so that you can.
Okay, so software testing,
Yeah,
also protection, right? So if you're going to do something that's potentially, virus prone or something like that, you might choose to do it inside of a virtual machine. You kind of get the machine set up, you create an image of it, so you got a good starting point. If things go south, you just delete it, move this guy over, start over, right? You have a good clean starting point with all the antivirus stuff already installed, so it's protection too. What's the downside to a virtual machine? Yeah,
It
significant,
will be
significant
using
use on performance.
It will be using same resources because you have
That's
the
it.
data.
So when we're talking about computing, we're talking about resource sharing, right? Okay. So what do you think? What's the slowdown? So how many of you? So this is probably more common for maybe a Mac user. Is you might virtualize Windows. So you're running the Mac OS and you have Windows running as an application in a virtual machine on it. You know, for PC users, sometimes you'll have like Linux running as a virtual machine or something like that. Now, which resources on your computer, so let's connect some IT stuff in here. Which resources in your computer are most significant when it comes to the performance degradation from running a virtual machine?
RAM, random access memory.
System memory comes first.
Do you think system memory is the worst?
Yeah.
Okay. Yeah, decent wrong answer.
Wrong?
I think
it would
System
have-
memory is important. All the resources are important. So let's blanket it with that. They're all important. Okay. Because system memory is so inexpensive, we can just get 16 gigs of RAM, give 8 to Windows, give 8 to the Mac, and everything. I mean, eight's enough, right? You're not going to really be hurting from having 8 in both sides. Okay. So important, but easily fixed. Right? Easily fixed with just a couple of dollars. You can get more RAM. Okay. So what's next on the chopping block?
Processor, something.
Okay.
CPU,
Processor. The processor would be more significant than the RAM.
No, we
Yeah,
can get
processor
two
will be because.
So you can get 2 processors. You can get a quad core, right? If you have a quad core, well, whatever. Whether a quad core or 2 physical processors, the same thing.
Yeah,
You know, number of cores is I mean, we could talk about it at the architecture level, but from this argument, it's the same thing. So you can give 2 of the cores to Windows, 2 of the cores to the Mac, and yeah, you got two dual core machines. You're giving up some performance, but you can get by with that, right? Okay, what's next? This is the most significant problem.
User interface.
No,
You just got one.
skipping the most important thing.
One is memory, one is CPU, and
Security.
No,
Me.
it's way more obvious than that. You.
User.
No.
I mean, I can't handle both of the systems at once.
resource allocation or something.
We are dealing with resources, but there's a very specific resource that is the major problem for virtual machine performance. It's a really obvious resource that every single computer has had for years and years and years and years and years.
Electricity.
Uh,
What kind of
the use of battery. I think the
It's really funny from my side that you just literally skipped such an obvious thing.
Performance.
storage is
Hard drive.
Storage.
Yeah, the hard
I think
drive.
storage is not going to be issue because storage we have already.
Huge issue. So I just told you it's a huge issue. Now you tell me why you don't think it's a huge issue, and then we'll figure this
Because
out
we
together.
were thinking every machine today have a lot of storage in it, and it is not going to be RAM. I was thinking still because RAM is a kind of we use it at the real time in the computer.
Okay.
And it
So
will
your
be-
argument is because hard drives are so big.
yeah, they are.
It's not a
big,
problem.
and it is not going to be an issue
Um,
and easily.
That's a misunderstanding. You're right. Hard drives are huge. A virtual machine is not going to suffer from us not having enough hard drive space. We're good in that regard. Okay. So now you're a pretty strong guy, right?
Yeah.
You can carry lots of weight at once.
Yeah, I have done
Okay.
a lot more labor work.
Okay. All right. So because I have a bad back, so
Oh,
if as long as I don't have to bend over, I'm like a bear. Yeah, I'm really powerful upright. The second I have to bend other ways, I'm like a porcelain doll, just gone. I'm just done. All right, so this is what we're gonna do. You're a hard drive in this example, okay? So I have an iMac in my office. I need to take it out to my car. Yeah, you could lift an iMac, right? No problem. All right. I also have a case of soda. Could you lift a case of soda? Okay.
Yeah.
Yeah, like a 24 pack. Okay. I need that taken down to campus safety.
The
Same time.
Same time, both of them.
Yeah. I need the iMac taken out to my car.
Uh-huh.
I need the soda taken to campus safety. Same time.
I cannot do that at the same
You
time.
can lift both of them,
I can lift,
but you
but
can
I
only
can
do
deliver.
you can only go to one destination at a time.
Yeah, I
Right?
cannot do it at
So the issue here is that it doesn't matter how big your hard drive is. You can only do one thing at once.
yeah, exactly.
It can give its attention to Windows or can give its attention to the Mac. And those two guys are competing for read writes. That's a major slowdown. Solid state's going to help.
Yeah,
Okay.
that's what I was thinking. Like,
Yeah.
450 megabits of speed.
Okay, but understand there's a difference between speed and access time. The speed will help because you still can't do two things at once, but you'll be able to do one thing quicker. He's taking the iMac out to my car at a sprint,
Yeah,
right? And then he's back before I know it to get the soda down to campus safety. He still only did one thing at once, but he was moving quicker. Okay, so those solid state drives are going to help us because there aren't moving parts. So so because there's not moving parts, there's less heat. And because there's less heat, we can speed them up without worrying about damage. Make sense? But we're still going to be limited to some extent with our technology. But you're absolutely right. Solid state drives will help with this problem, just because we can push them faster. You know, before that, if you wanted to have a mechanical hard drive, they usually were measured in RPMs, right? So a cheap laptop hard drive was like 4,200 RPMs, and then your average desktop hard drive was 5,400 RPMs. The faster ones were 7,200 RPMs, right? If you've ever been shopping for a laptop, and you can get a 1 terabyte hard drive, or you can upgrade to a 500 gigabyte hard drive for $100. Why would you pay $100 more for half the capacity? Because it's 7,200 RPM, faster performance. So then on desktop machines, you can get 10,000 and 15,000 RPM performance drives for like gaming computers. So yeah, there's Western Digital made a Raptor, Western Digital Raptor hard drive, which was 15,000 RPM. Huh?
The black color?
I think so, yeah. It had like heat sinks on it. Yeah.
I didn't know.
Yeah, I think it was maybe 200 gigabytes was the max size on it. And that was when 1 terabyte drives were out, because they made it smaller to spin up to get the higher RPMs. They took away capacity to put more heat sinks.
They are trying to make an SSD out of a traditional hard drive.
Before SSDs, yep. So they were trying to take a traditional hard drive and spinning it as fast as they can and dissipate as much heat as they can. So as you get to higher performance hard drives, we're going to feel this problem less. But hard drives can still only do one thing at once. Make sense? Okay. So you can sprint with that iMac, and you can sprint with that soda, but I'm still going to have to wait for you to do one or the other. That's the slowdown with the virtual machine. Make some sense?
Yes.
Okay. So and these are really important concepts for IT, not just programming. I mean, for programming, this idea of a virtual machine is going to be important for us just to kind of understand where we came from, right? But from an IT perspective, virtual machines are very much a common tool you're going to use. Okay, so I'm going to encourage you guys to, do we have any courses that kind of talk about some of the stuff I just talked about?
No, not in the.
So just me?
Kind of how you doing TV says human-computer interaction, but it will not be.
Yeah, that's more
That is
interface
like
stuff.
Interface
Yep.
and front-end stuff. No,
Well, you won't get me for any other MSIT courses because I refuse to teach them.
No. MSIT?
Yeah.
But I had still 3 to 4 subjects. Actually, I'm taking one.
Not with
I
me.
was kind of talking to the Jacob Hobby, Professor Jacob Hobby, we can talk a little bit, and I want to change it to the programming your courses rather than taking those.
Yeah, I mean, we can talk to Dr. Locklear or something and see if make something like that can make sense.
Because
But
I will take the courses which are compulsory to take, and the courses which I can take, or
I get it, yeah.
change it with something more.
yeah, like Shiva's taken some of our MSCS classes.
Yeah, I want to take something like that.
So,
If I recall, I kind of did like resource allocation with my desktop computer which I made.
Mhm.
I had a 500 gigabyte hard drive on there. It was 7,200 RPM. Then I had 1 terabyte with 10,000.
Yep.
So I put all my games on 1 terabyte, and all the other ROM of 500 gigabyte, which we're used to run my desktop computer.
Yep.
So I was able to access that.
Yeah, so the game wasn't competing with the operating system.
Yeah, it was like smoother performance.
Oh, absolutely.
Yeah.
That's the way to do it. If you're going to run a virtual machine on a computer, get a second hard drive
Second hard drive
Yeah.
and put the virtual machine on the second hard drive. So it's only competing with itself. Yep. You'll have a little overlap from the operating system having to sometimes do writes over in that second one related to the file system, but way less. We're probably talking 85% reduced performance hit, I guess, something like that. So it'll, but you know, in any case,
There's
it's a,
always room for thinking more.
Mhm.
What can you do?
well, but so here's kind of evidence. I mean, so those are all topics that are related to technology. Doesn't matter whether it's IT or computer science, right? We're all in the same
In
pool.
general, you have the
Yeah.
kind of basic knowledge and updated basic knowledge.
Yep, absolutely. All right, yeah. So if you want me in for more classes, you got to take the masters in computer science ones.
Oh, wow.
So my PhD is in computer science, not IT.
Oh, it is in computer science. I was more.
We created the programming
Yeah,
classes for
I
me to
was
teach
more-
it.
Walking.
class in computer architecture.
Yeah, right now he's in 548, which is the CS.
I should have done.
No, that's MSCS.
Yeah, oh, CS, yeah. I told him the same thing. I want to enroll in Dr. Littman's class. What you got for me? He's like, no, it's a CS class, so you gotta be asking him to get into that. So he's never.
Yeah. So right, so depends how far you are into the MSIT program. I mean, we have been trying to help some of our MSIT students who probably would have done computer science if we had it. Kind of take a couple courses over on the CS side to count them for some classes in MSIT, but we need to be careful about that so we don't create a precedence. You don't want to have everybody doing that. I think typically my classes are hard enough that you're not going to have everybody wanting to jump into them. They're fun but hard, I guess. Something along
We
those.
need some time to it, and that's what we are here for, to improvise ourselves.
You need to
Well, not everybody.
put a lot more time in the week. You will come to know. I have an intern. I think last class I have one. I think one night I didn't sleep till like 48 hours or something. On stretch I was doing something.
But doing my assignment?
Yeah.
Did you even get it done?
I get it done, and it was like there's still a little bit missing.
See,
And then
just dummies.
yeah, I have to like.
The funny thing is that I come to class and I solve it like in 45 minutes.
It looks so simple when it is like done here.
But that's why I do it. The reason I do live programming in class so you can see it being solved is so that you convince yourself that it's possible.
It is like so simple, and even like you say, why is it so simple? Why I was not able to like think like that. I think more practice and things like that. Yeah, it will do. I will try. That's how it takes.
That's all I ask.
Yeah,
I like effort.
that is what I can do. That is
You're supposed to suck for a while at programming.
I still suck. I know that, but
Do you think that I mean, he hasn't seen me program yet, but I'm good. So,
it seems so
but I
easy.
didn't
It seems like
just
nothing.
pop out of the womb able to program.
Because
How many hours do you think I spent making all the same mistakes that you've been making?
I don't think any of that you make any of.
Oh yeah.
I never
I already made all the errors. That's why I don't make very many of them in class. Been there, done that. I started programming when I was 9.
Yeah, I had kind of. Oh,
Yeah. Yeah, I have a form of autism called Asperger's syndrome. Have you guys seen the show Big Bang Theory?
Yes.
Yep.
Sheldon, I have the same thing Sheldon has.
What does he have?
It's called Asperger's. It's on the autism spectrum. So we tend to be really sharp at like math and science,
Oh,
but very one-minded. So my friends were out, playing sports and stuff like that. I was inside writing code as a 9-year-old.
9 years.
I played tennis because my dad was a tennis player. So he kind of pushed my brother and I into it. I was good at it, but my brother loved it. Just I don't know, I must have gotten some of my dad's talent genes for it or something like that. But yeah, so I'm wired funny. You're getting a filtered version of me. At home, I'm much quirkier, much more like Sheldon.
I like sugar.
Well, no, he's what makes the show funny. So living in my house is like living with Sheldon. My wife references it all the time. But see, when I was younger, I was the weird kid. So you can do two things, right? You can either fall into the shadows and get ostracized from that, or embrace it and be the weird kid, right?
Yeah.
That's what I did.
Oh.
So I'm the weird guy. I wear crazy ties, with golf shirts.
Until they know us from the name weird kid.
Yeah, exactly. All right, so let's keep trucking.
There was, I think, the biggest quote of, I think, the same Microsoft. He said, just be cool with this kind of kids because you might be working for them tomorrow. Just be cool with them.
Be cool with the nerds,
Nerds.
because they might be your boss tomorrow or something like that.
No, yeah, exactly. Be nice with the nerds.
I gotcha.
You might be working for them tomorrow. Okay.
So when we brought in Java, we kind of took the memory control away from the programmer. But then what we did is we also moved things into a virtual machine. This really had it had one legitimate benefit. We're going to call that security. All right. So not only did we kind of reduce the advent of memory leaks because the programmer is no longer in control of memory, we also compartmentalized your program running inside of a box so that anything bad that happens inside there dies inside there. It doesn't hurt the rest of the operating system. Where with an older language like C++, you could potentially overwrite part of your operating system in memory and have to restart your computer to let the OS reload into RAM. That could happen in C++. All right, so Java kind of protected us from that. Now, what their claim to fame was platform independence. Write once, run anywhere. So you could write your program on a PC and run it on a Mac or run it on Linux because your Java program compiles to Java bytecode, which runs on the Java virtual machine. The Java virtual machine was written for Windows. It was written for Linux. It was written for Mac. It was written for Solaris. It was written for cell phones. Okay, so they ported the Java virtual machine to all the different platforms so that us as Java programmers didn't have to port our software. We can write the software once and it is built to run on the the JVM, the Java virtual machine. Okay, now that has two problems. One problem is the consistency of performance. Just because the program that you wrote in Java is compatible with the virtual machine for Windows and the virtual machine for the Mac, that doesn't mean that those two guys have equivalent performance. The Mac might do certain things faster or more efficiently than the PC version of the virtual machine, and vice versa. Okay? Not necessarily a huge problem, but if it's a time-sensitive thing, you're not necessarily dealing with equivalent applications, right? The real issue was, and this is even something we've covered in class today, there was a misunderstanding of the performance impact of a virtual machine. The reason why it was believed, well, here, we'll see if you guys come up with this. Why do you think back in 1995, let's say, 1994, when Java came out, why do you think it was considered important for programs to be platform independent? Why was it important for a program to be able to be written for the PC and also run on the Mac, or written on the Mac and also run on the PC?
Save money.
Okay.
No, to have a common kind of language because the programmers at that time have to go this way for the Windows or for particularly Mac and write the programs. Maybe this gave them.
Let me rephrase the question. Who do you think was complaining that not enough software was running on their platform?
I think Mac.
Mac people,
Yeah.
right?
Yeah. They don't have much.
So Now, would we all agree that Apple is way more popular today than it was back then?
Yes.
Okay. What percent of computers in the world today are running Windows versus the Mac OS?
Like Windows.
Microsoft has lost some of its market share, right?
Yeah.
What do you think its market share is at right now?
It would be still 90 Windows because all the offices everywhere.
Over 90,
Like
yeah.
Windows. Is
It used to be 98%. Now maybe it's 96,
Oh, it is all.
Okay.
Yeah.
95.
Everything
A
is
very, 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 very high percentage of desktop computers, even today in the world that Apple has taken over, is running Windows, right? Macintosh users tend to squeak pretty loud, but there are a very small number of people in the big scheme of things. Now, when you start getting over to the mobile devices, this becomes more of a competition. You know, you're dealing with kind of 50-50 iOS versus Android. The numbers get a little skewed in statistics because there's so many unique Android devices. But in terms of user base, that's a much more even competition. iOS versus Android over there. Microsoft doesn't play that sport. Like legitimately, they have Windows Mobile, but you know, it's like 0.01% or something, you know, a very small market. But Microsoft owns the desktop operating system market. They're never going to lose that. Eventually what will happen is the desktop market will just disappear. We'll replace everything we currently do on desktop with the mobile operating systems. We're not quite there yet. I mean, I do everything on mobile for the most part, but I still have to program on desktop. Right?
You cannot replace that.
But we will. I promise
Maybe
we will.
Yeah,
We will definitely do it. But that's when Microsoft will lose its spot.
I think Microsoft will itself do it by themselves.
They already sort of have.
Yeah.
Yeah, I mean, Microsoft was really waning in that mobile market, but with the Surface Pro tablets,
Right now.
that's a win for them. The early ones sucked. They just didn't have the battery life to keep up. But the new ones, where they put most of the hardware in the keyboard, so it's a tablet, you know, a lowish.
It's like you can even
Yeah.
they got new desktop kind of system, the
Yeah.
big and it can for the artists and things
Mhm.
like because I was considering more like graphical designer,
Sure.
artists and things like that. They use Mac, but the programmers, real programmers and professionals use Windows because Windows is everywhere.
Yeah, it's all the same.
But right now, the surface changes that they got, like they can touch, they
Mhm.
can change something, they got other devices with it.
Sure.
They have to-
You know, so the idea here is that back then there was this erroneous perception that cross-platform compatibility was important. You know, you said something about saving money, which I mean, fine, it might be true. But if you're a developer, a software developer back in 1995, do you really care about the Apple people? If you're writing software, you're going to sell your software to 100, you're going to try to sell it to 100 people. Don't you really want to make the 98 of them who are running Windows happy and just kick the 2 people who are running Mac to the curb?
Yeah.
Get with the program rather than hurt the performance of your application by writing it in a cross-platform language like Java. Okay. And the things they were complaining the most about, the Macintosh people, were games. Like, oh, well, why didn't game XYZ come out for Mac? Why is it out there for a PC? Well, because the game designer wants to feed themselves. I mean, what are these Mac people, idiots? Okay. So I'm here knocking on Mac. Why am I a Mac user? Why am I sitting here in front of you using a Mac?
It's just simple and efficient.
Maybe right now.
I actually think a lot of people say the Macintosh operating system is they say it's easier to use. I actually disagree with that. A good friend of mine who's not really a technical person once said, hey, on Windows, at least you know where to start. Click the start button. That's where Microsoft went awry when they took away the start button in Windows 8, right?
Yeah.
So that's why they brought it back in Windows 10.
It was disaster.
You know, so but you know where to start. I'm not sure that somebody who is if you put Grandpa in front of a Mac and a PC, I think he might have an easier time on a PC. Once you got him set up on the Mac, where you just have all the icons on the bottom, then maybe, you know. But so why am I a Mac user?
Maybe you have both your.
Play on it while you're in class.
Well, wouldn't I be a PC user then? I can get a better gaming machine if I had a PC laptop.
Yeah, you can do that, but you're not doing it because you don't want to. You want to teach us class.
Well, yeah, but is there anything I've done today that couldn't have been done on a PC?
Maybe you want to.
Am I just showing off like driving a Cadillac or a Ferrari? It's like, I can afford this guy, so.
Status?
No, it might be because you want to touch this part as well because already you have such a kind of knowledge of you want to learn both the systems.
Okay. See all these stickers back here?
Yep.
What do you think those stickers are?
I'm gonna get them. I already got sticker paper for 89 cents from Office Depot.
Oh, this is just.
These are all programming competitions.
All right.
So all these stickers are from hackathons that I've competed in.
Just on the 12th of November.
Yeah, we're doing one here. I'll be at that one.
12th of November.
So I've done like professional programming competitions. I'm a programmer.
I don't have.
I was talking about gaming stickers.
Yeah. No, none of these are gaming stickers. They're all program.
Like trophies?
They're all like programming competitions that I've competed in. I've won a bunch of them. But punchline is this: a Mac is not better than a PC. Buying a Mac for a technology person like me, where I write software for all sorts of different things, I get 2 computers for the price of 1.7. Are Macs more expensive? Sure. But they're not twice as expensive. I have Windows dual booted on this. If I'm going to do .NET development, or I'm going to do something that is Windows centric, I'll boot into Windows. I won't virtualize it. I'll just boot into it. I'll use Windows for a week or two while I'm working on that project. If I'm going to do it, I do a lot of iOS, iPhone development. That's probably my go-to move. I prefer iOS development. So I need the Mac for that. So I'm on the Mac side for that. So I have everything I need in one machine for the price. So I have 2 computers for the price of 1.7. When you look at it through that lens, it's a value. Does that make sense?
I think you can install Mac on PC, right?
Yeah, but it's buggy. You got to use, there's a program called Hackintosh that you can kind of pull it off. I mean, if you get the right hardware, you can almost pull it off, but you don't want to be testing software on that. Yeah, you want more stable. You want stability. So that's the punchline. I have a Mac because it gives me everything that I need to develop on both platforms. That's it. These machines all have the same crap inside of them. This is actually an older Mac. They're gonna announce the new MacBook Pros tomorrow, so I'm gonna get my new one ordered. I'll lose my stickers, but I'll get my new one ordered tomorrow. But this is from 2012. But this is a quad-core i7 with 16 gigs of RAM in it from 2012. That's a pretty high-end machine from 2012. So I'll do the same thing in the next one. I'll just everything they can put inside of it, that's what will go in there because they're all soldered now. And then I'll just use it till it dies. I've already had to replace the motherboard in this and stuff like that, just waiting for them to release the new MacBook Pros. Okay, but the punchline is that as a technologist, it's the right tool for the job for me because I write a lot of software using a lot of different technologies because I use the right tool for the job. In terms of programming languages, so like we talked earlier, like, you speak 2 or 3 different languages, 4 different languages, whatever. I've probably worked in 30 different programming languages. But the point is that we've already learned in here, they're all the same. It sounds impressive on paper, but it's the same crap.
The baseline is same.
It's the same crap. When you switch to a new language, yeah, maybe there's a 2 or 3 hour learning curve just to kind of get up to speed. And then before you know it, you hit your stride, and you're off to the races, right?
It is all up to here. How did you think about it and how you solve the
That's it.
problem?
All right, so the issue with Java here is they really tried to play this game that you're like, oh, well, we need to support platform independence because it's important to have the crap running on both PC and Mac. Okay, when really the people who were complaining were the people that are complaining about the video games not coming out for Mac. Okay, business users used Windows, right? They use Windows anyways. Now, Java is perfectly appropriate for business applications. Cross-platform, like effectively, let's say something like Microsoft Office, Microsoft Word. As a cross-platform product, we have something, Open Office.
Yep.
Open Office is a Java product.
Oh, that's the Java.
Yep,
product.
it's a Java product. So it's written so that it's platform independent. It runs on Mac, it runs on PC, it runs on Linux. It's all the same. It's a Java program. So that's taking advantage of Java. Okay, but you're not going to find Dota for Mac written in Java. The performance needs to be better than that. We're not going to put up with a virtual machine just to be a virtual machine. We'll just say, screw the Mac people, right? Does Dota have a Mac client? They might.
It does.
Okay. I know League of Legends does, but it's not uncommon for games not to have Mac clients, right? It's more common today for there to be a Mac client just because Macs are more popular today than they were before. They're not more popular than Windows. Now, a lot of people have a Mac laptop and then have a gaming PC at home. Yeah, that's pretty common. Yeah, that's a pretty common, like, kind of go-to move. It's like, this is my work homework thing, and then I have my gaming machine at home that actually can do stuff.
Laptop, coffee shop.
Yeah, right. All right, so that's kind of Java's story. So back here, then we got C#. Okay, so we'll just make this one real quick. Microsoft tried to steal Java, released it as a product called J#. Sun Microsystems, who had, at that time owned Java, they sued Microsoft, won. Microsoft then came out with a brand new programming language written from the ground up, blah, 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 called C#. C# is Java without the virtual machine. But it is an upgrade. Notice how I have it drawn here. I have C#. Think about this like an evolutionary ladder. So C# is a little bit more evolved than Java. Okay? And I'm just going to quickly show you this. So the Java model is, so here, this is Java. So we're going to say source to Java bytecode to running on the Java virtual machine, which then runs on the CPU. Okay, so this is our slowdown. So we take the source code, we compile it into Java bytecode, which is a low-level language that knows how to run on a virtual CPU, which is the JVM, which then converts that one-to-one low-level language from Java world into native CPU world. Okay? So this is our slowdown there, that translation. It's a one-to-one, it's a low-level language being translated into another low-level language. So the hope would be that translation is quicker than high-level to low-level. Okay? But it's happening during runtime. Now, C#. We have source. Okay? And this turns into missile code, Microsoft Intermediate Language. Okay? Which then runs on the .NET component architecture, which then runs on the CPU. Both of those things look pretty much the same to me. They just name some things differently, right? Okay. There's one very, very important difference. The move between missile code and the CPU here through .NET only happens one time. What ends up happening here is when we go through the .NET here, it goes into something called a just-in-time compiler, a JIT, which translates that missile code into native code for the CPU. So the very first time you run a .NET program, it takes a little bit longer to run because it's doing that translation. From that point forward, when you run it, you're running native CPU code, no longer translated.
Directly MSIL to CPU.
Well, actually, what ends up happening is after you run it once, you end up having native bytecode, assembly code for the Intel CPU. It's native. It's a native application at that point. So you do the conversion once. Now, Java has learned from this, and they've introduced some just-in-time stuff in there. But because they don't have as much control over the operating system as Microsoft does, obviously, they can't quite pull the same thing off. Now, Microsoft, so we're going to say this is an improvement, right? But wait a minute, what about the platform independence thing? Because that is important for business applications. Games are out the window. We're not going to do this platform independent crap with games. Okay? But for business applications, Java can keep up. Our computers today are fast. Okay, so Java can keep up with those. So we already said that Java is platform independent. And down here, Microsoft says it's platform independent. Independent.
It is.
Absolutely. Microsoft says it is. It must be.
So it is better than the.
So Microsoft says this. Say, look, gotta use C#. Gotta use C#. It's platform dependent, just like Java. Higher performance than Java. It'll run on any operating system at all, as long as the .NET component architecture is available.
Oh, and
Just like virtual machine. Java says, hey, our software run on any operating system as long as the Java virtual machine's available. Same comment, right? So, hey, it'll run on any operating system. Any operating system at all, as long as the .NET component architecture is available. .NET component architecture is only available on Windows. Microsoft wrote it. They weren't. I mean, what's in it for them to port that over to the Mac, right? So really what they said, hey, look, it's platform dependent as long as the platform you're running is Windows. It'll run on any platform at all, as long as it's ours. But technically the technology would allow it to run on any platform if Microsoft ported .NET over to the Mac, which they are doing. Microsoft is porting it over. There's actually, you can do C# programming on the Mac through a project called Mono, which since .NET is is proprietary. So what Mono has done is they've written their own, let's call it .NET Clone, what they believe is all the functionality of .NET for the Mac. So you can use Mono to write applications on that side using C#. But I don't know that makes a whole lot of sense, because really the strength of .NET and C# programming really lies in the programming tool, which is Visual Studio. You know, if you use Visual Studio to write C#, the language, like we've already discussed, languages are languages. It doesn't matter. You're gaining if you're going to go with a Microsoft technology, you want to stick with Microsoft throughout, because it all integrates very well. So you want to use .NET, C#, you want to use Microsoft SQL Server for your database, you want to use Microsoft Azure for your cloud stuff, because all that stuff integrates nice and cleanly using Visual Studio. Make sense?
Yeah.
Same thing's true on the Mac side, right? You know, if you're a Mac user and you're an iPhone user, then you probably have an Apple TV if you want to have a set-top streaming box. If you're an Android user and you're a PC user, you probably have a Chromecast as your set-top box. They're both fine. It's the one that makes the most sense to you. I can control my Apple TV from my Apple Watch. Why do I have an Apple Watch? Because I write software for it. Before that, I didn't even wear a watch. The whole world's just filled with gadgets, right? You know, they're all good. You know, we're lucky today as consumers that we have, in the mobile world, we have two top-tier competitors that keep trying to knock the crap out of each other.
And giving us more and more technology.
Yeah, I mean, you know, it's not like Google or Apple suck, right? These are both like top-tier companies. They're going to keep one-upping each other, and then this guy will steal from this guy, and this guy will steal from this guy, and who benefits? We do. I'm cool with that.
I'm fighting and give us benefits as soon as possible.
Yeah, what do I care? Now, so out of curiosity, why do you think, if I'm sitting up here, I'm saying, hey, I'm an Apple guy, you know, iOS, I prefer iOS programming, why do you think we're doing Android in here?
Trending?
Trending? Probably in the wrong direction. From a development perspective, Android is clearly the weaker platform. Yeah, clearly.
Because Mac was not using in the phones, or we are talking about the general? Mac,
Cool.
I think, was not in the phone system, was not using that.
No, I mean right now. Your homework assignment for next week, it's already up on Blackboard, is to do there's an Android programming tutorial. Why did I pick that instead of having you do a iOS programming tutorial?
Because there is more kind of.
This Mac is proprietary and Android is open source.
Okay.
Yeah, we don't need license for that.
You don't need. I mean, Xcode, the software to write iOS programs, is free. You can get it off the App Store for free.
Because there is more customers and more people who are using Androids and Android's apps, I think.
Okay.
And it is platform independent. We can use any of our systems.
So I'm going to hold that question. We're going to come back to it in a second. We're going to throw Swift in here real quick. Okay. Objective-C sits up here where C++. This is the Mac side of things. Okay. So let's go ahead and throw Swift down here. All right. So Swift came out, I guess, a couple years ago now. A year and a half, 2 years ago. 2 years ago. Apple announced it at their one of their worldwide developer conferences in San Francisco. Hey, greatest thing since sliced bread. Notice I have it down here farther in the evolutionary chain. Because Objective-C, which what was the Apple language before. So you did early iOS programming in well, really, you did like Uber. Like I teach, I do the onboarding stuff for Uber. So when Uber hires a new Android or a new iOS developer, I teach them instead of Uber doing that stuff. Uber still uses Objective-C for their iOS stuff because that application has been around for a long enough time that it makes more sense to them to keep it in Objective-C than to port it over to Swift. All right, so I have to teach them the Objective-C way of doing things. In fact, in many ways, I prefer Objective-C to Swift, but whatever. I use Swift today because that's what everybody's using. But punchline, and part of the evidence should be just the fact that I just said I prefer Objective-C. Even though Objective-C has been out for a long time. It's old. It's C++ vintage. Why do you, when we went from C, procedural, to object-oriented, why do you think that we had C++ and Objective-C split there? Why did we need two?
One was for the Mac and one was for the Windows.
Yeah, Microsoft and Apple didn't really agree on stuff. So if Microsoft's going down that fork in the road, we're going to go the other direction, right? For no other reason than it's the other direction. Make sense?
Against you. Yeah, just.
Until recently, Macs would boot off of a FireWire drive, but not a USB drive. PCs would boot off of a USB drive, but not a FireWire drive. At the hardware level, they couldn't agree with each other. Even when they were both Intel.
It's like still we need to have a little bit change something.
Okay. Well, here, so I'll throw another history question out there, though. So is Apple wrong being proprietary?
I don't think so because it bought competition and things like that in the market. Yeah, and
Do you wish Apple was not proprietary?
I don't.
You like that they're proprietary?
Yeah.
Okay. What about you?
It really doesn't matter, I guess.
Well, do you think it's better for them that they're proprietary, or would it be better if they were more open?
Yeah, it would be more better.
It'd be better if they were more open? What do you think?
I think they, but
It's better this way.
I
they
think it is
provide more
better
security.
because
Okay.
they are kind of creating some different. They are working very hard. That is not. They are not working on their machine. Or their machine is not. They are really good, and I think it is better to have kind of competition and have kind of proprietary.
Okay.
That will kind of help.
So the Apple we know today, how long has that been around? How long has Apple been around?
I think 2022,
23 years.
Okay. So we're getting close to Halloween, right?
Yeah.
So people dress up during Halloween.
Coming Sunday.
Right? Yeah, we dress up during Halloween. So Apple is a company that's been in costume for a while. So years ago, Steve Jobs was fired from Apple,
Yeah.
right? Okay. Company he founded,
Yes.
he was fired from it. Publicly traded company, they have a board, kicked him out. What did Steve Jobs do when he left Apple?
He made the
He supported
Company.
Microsoft, I think. I don't know. I forgot the
He
name.
made the another company. company, I think, iNext or something.
Next Computers. Yeah, he started another computer company called Next Computers. It was supposed to be kind of the best of Apple and PC, kind of a hybrid type thing. He also he had a buddy, George Lucas. You know who George Lucas is? Star Wars guy who made the Star Wars movies. George Lucas was going through a divorce at the time, and he needed some money. So he sold Steve Jobs a small company. You probably haven't heard of it. Pixar?
Pixar, yeah.
It's not a small company.
Pixar.
Yeah, so Steve Jobs bought Pixar for, I think it was something like $7 million back then.
At that.
Years later, he sold it to Disney for something like $8.5 billion. And still controlled it. Still the head of the board. So, yeah, it worked out okay for him, right? So, what did Apple do after Steve Jobs left the company? We were just talking about proprietariness a few minutes ago.
Yeah, I think they dropped the ideas of making the
They
Mac
tried to
machine.
expand to other platform. They tried to take some things from other platform, what they developed into their platform.
Okay?
Not keep it kind of private or different thing. They try to just
They tried to become less proprietary.
Yeah, that's what.
You could make Mac. There was a time period where you can make Apple clones. Like Macintosh computers came out. Not only Apple was selling Apple hardware. You could have a clone. What happened to Apple during that point in time?
falling pretty badly.
Stocks went down.
They almost failed as a company. In fact, I'm here to tell you they did fail as a company. The Apple today is not the Apple that's left over from back then. Steve Jobs came back. Now, did they rehire Steve Jobs? Under what circumstances did Steve Jobs return to Apple?
He must have changed all the board and everything.
I think he demanded an apology.
No. I think more share and to introduce the last thing again that we will be a proprietary.
So you told me that Steve Jobs founded a computer called Next Computers,
Yep.
right? So Apple acquired Next Computers.
Yeah, they bought
And who comes with Next Computers?
Steve Jobs.
Steve Jobs. So Apple bought
Company for Steve.
a company which came with Steve Jobs, who they then installed as the CEO, the interim CEO, right? So that's when he came out with iMac, iPod, iBook, iPhone, everything, right? Okay. I'm going to show you something here. This is documentation from the most recent. This is going to be Swift. All right, so this is a up-to-date API class reference for the Swift programming language, which I'm showing here is way down the evolutionary chain. I said it's only been around for a couple years. What do you think NS stands for?
Next to something.
Next step.
Next step string.
The software level, Apple is Next Computers. What we see today is that what we call Apple is Next Computers with an Apple logo on it. Apple died. None of us noticed.
Yeah.
It's company in costume, right? So it's written in the software. Next Computers is all over it. Okay.
I noticed that they got the hardware from every other company.
Yeah.
And Apple.
But the evidence there is that Apple, when they tried to become less proprietary, almost failed as a company. That doesn't work for their model, which actually then takes us to starting to wrap up this conversation. A couple of years ago, when Apple came out with Swift, people might have looked at that from the outside and said, oh, well, long overdue. Look at all these upgrades that happened over here in the middle. Why did it take so long to upgrade this archaic thing to Swift? How many of you guys have ever been in an Apple store?
Yeah.
Been in an Apple store before? You've been in one. Have you walked into it? You've never walked into an Apple store.
I don't know.
Well, that's fine, but you said you've actually never been in an Apple store. Okay. But you've been in one, right?
Yeah.
Okay. You get a feeling when you're in there. You're kind of wondering where the Kool-Aid is, right? It feels culty, right?
It's different.
I mean, it feels like a cult. Like Apple is a cult,
Yeah, it's like
right?
standard.
And you don't like them, so you would agree with that, right? You would think Apple is there's something not right with them. You know,
Something's not right.
you've heard the thing that you're all drinking the Kool-Aid. Have you heard that phrase before?
They got Kool-Aid with it?
Well, no. Drinking the Kool-Aid means you're all following the cult. You're all following the dictator person who's calling the shots. So it's like a religion.
That's why I don't like
Yeah,
it.
kind of like a religion, right? So the question is, so if we're all going to agree that Apple fanboys tend to just follow Apple for whatever reason, right? They don't. It doesn't matter what Apple does. Apple could literally come out with toilet paper; they'd love it, right?
Yeah, just a little more.
Do you think these people were complaining?
No.
If you're an Apple developer, you're using Objective-C, and I've already sat here and told you I prefer Objective-C today to Swift. You're not bitching. You're already drinking the Kool-Aid. Okay?
It is the-
You're praying 3 times a day to Steve Jobs. Right? You're indoctrinated already.
You're already-
You're already in. These guys, they weren't complaining. This came out 2 years ago. Who was Swift for? Swift looks a lot like Java.
the Java.
Swift looks a lot like some of these languages over here. Like, hey, fellas, come over here to the dark side. Hey, fellas, come over here to the dark side. Swift exists to get non-Apple developers to come over to the Apple ecosystem.
To develop for you.
Make sense?
Yeah.
These people were not complaining. Objective-C is fine. Make sense?
Yeah, it is already their guide, so they're not going to change.
Yep. So, having said all that, I know we're pretty much out of time. I'm going to babble for at least a couple more minutes here. Why did I pick Android? Why are we going to do Android development in here? 2 reasons.
Android. One is I think what should be
One is an educational convenience reason, and the other one, well, I'll give you one of them. One of them is because the development language for Android is Java.
We can use Java.
You've already done Java, right? So we've all been exposed to Java. Have any of you been exposed to Swift or Objective-C?
No.
Okay, I'm telling you all languages are the same, so it wouldn't be the end of the world. But you're familiar with Java more so than anything else, and since we're beginning programmers, that's gonna be the easiest point of entry. That's one thing. What's the other thing? When you hear Java, what does that instantly mean to you? Platform independence.
It is going to be
Okay.
if we go home or something.
He hates Apple, so you don't have a Mac at home.
No.
Okay? How much would you like me if I made you come into the lab down there to do all your homework?
And it is not going to
How much would you like me as a teacher if I forced you to come into the lab down there to do all your homework?
I would like
You would.
if there's Windows on it,
Seriously?
Well, yeah. I'm just saying, wouldn't you prefer to do your homework at home?
doesn't matter.
Oh, you come in here from Chicago
It is not going to
Oh,
be.
come here just for the homework.
to do your homework?
Yeah.
Again?
Yeah.
If I get a good grade,
No. But the point is, you would prefer to do your homework at home.
My home.
Yeah. But you don't have a Mac, right? So you would probably be upset with me if I gave homework that you needed a Mac to do, correct?
Drop the glass. Drop the glass.
Me right?
It's so costly,
Yeah.
Or I could just buy yours when you get a new.
Well, but the point is, so from an academic perspective, I could have you do Android. It doesn't matter what kind of computer you have. You're going to follow this tutorial. The assignments, the paper is up, and the other assignment is up, so they're due a week from today. But the instructions are the same, whether you're PC or Mac, because you're downloading Java products. Make sense?
Yeah. Yes.
Okay. So I prefer iOS development. I like Android. Plus, Android changes every 5 minutes, so there's always we get some fun in class when we're trying to solve a problem because they changed their interface since the week before. But whatever, it'll be fun. All right. So the homework assignment for next week's already up. So there's 2 things. One is a paper. It's a 2 to 3 page paper dealing with. So you all are familiar with arrays. You did arrays in the. Okay. So you know what an array is. Good. So we're where we need to be. All right. So the paper is going to deal with the difference between something called a linked list and an array. Okay, so you'll have to do some research and read about linked lists. We'll talk about linked lists next time. But one thing I'll kind of preface you with is don't view linked lists as upgrades to arrays. Because one of the things you're going to be learning about in this paper is there are reasons when arrays are the right tool for the job. There are reasons when linked lists are the right tool for the job. They solve similar problems, but there's pros and cons to each. So the paper asks you to look into those reasons, the difference between a linked list and an array.
Discussing the linked list and arrays, or do we go a little bit like what is file system and then
whatever you want. Yeah, I mean, I really want you to focus in on the difference between them, the difference between the things, and why, under what circumstances would you use one versus the other. So really you're learning about the pros and cons of each. Okay, so 2 to 3 pages. I don't care about format. If you want to double space, that's fine. I don't care about MLA crap or anything. Just, I would encourage you not to just copy huge swaths of text from the. I want you to read it so you can understand it. Again, my exams are worth enough for your grade that it doesn't matter if you ace everything else. You'll fail the class if you do poorly in the exam, and I grade on competence. So use the homework as a learning experience. Otherwise, it's just busy work, right?
I know that.
Okay, but if you feel like your writing isn't strong, I would highly, 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 highly encourage you to just take it by the writing center and have them proofread it. That way, when I read it, it doesn't read like broken English. Because you'll lose points for that because that's part of our accreditation. Because one of the things I'm grading you on is your ability to communicate with English speakers. Okay? So if you feel like your writing is subpar, that it's going to sound like it's broken, take it to the writing center. It doesn't cost you a dime. Have them read your paper and have them give you some help just to replace a couple of sentence structures with some better sounding phrases or something. Make sense? It will save you so many points. Okay? Just take the little time, do that, and an 80 will turn into a 95. Okay? We're talking a big difference. So students never listen to me when I tell them to do that. Just do it. Just suck up your pride and go in there with the paper and have them read it and say, okay, how do I make this not sound like broken English? Got it?
They make you read it first loudly.
Yeah.
Then when you read it loudly, you come to know, because when you read it, you feel like, oh, it doesn't sound good.
Yeah. So I highly encourage you to take advantage of that. It's free, and it'll help your grade. Okay? And we already decided he's grade motivated. So
I am?
yeah, you said you are. So you'll do whatever I tell you to do as long as it helps your grade.
Oh.
Don't change your mind.
I love this guy. All right, and then the other assignment is to go through, and I'll give you the link to it, is to go through the Android tutorial. I think I just had it back here on screen. So this guy, building your first app, I give you a link directly to this. And notice it gives you a dependency for Android Studio. So you'll have to go over here to Android Studio and it'll take you through the downloading it and installing it on your machine and making sure you get all the stuff downloaded for it. So it takes a little bit of time to put all the packages together. You might also find that there could be some YouTube videos that you might prefer to follow instead of the reading. There's plenty of Android Studio tutorial stuff out there. But by next week, I'm going to expect that you have Android Studio installed and working, and you've proven that you have it working because you've gone through this build your first app thing, which creates an Android project, runs your application in the emulator, you build a simple user interface, and then you launch a second activity, a second screen in your app. So a very simple app just to kind of get your beak wet. Make sense?
Yeah.
All right. So questions, comments, concerns, bribes.
Sure.
All right. I will see everybody next. What day is it? Wednesday.
Oh, I
Yes.
think it's
Yeah,
26th.
So week second week from today.